Hello, everybody. I am David Sankel, and this talk is about Rust features that I want in C++. I am a principal scientist at Adobe. Well, that's half true. I will be a principal scientist at Adobe in like 2 weeks, but but close enough, right? So just the basic format of this talk is we're going to go over some Rust features. We're going to talk about what they are, why they happen to be useful, and there's going to be a gap with C++ to meeting this Rust feature. We're going to talk about how this gap can be closed, okay? So we're going to cover a lot of features. We're going to talk about language variants, reflection, a whole bunch of different tools for systems engineers, concurrency, community. And anyway, you're going to be thinking like you're biased, you're totally biased. And you're right, I'm biased. So let's just talk about up front what my biases are. And you can see if that aligns with your biases. And the more it aligns, the more useful this talk will be. So what are David's biases? First one, I work on large systems, big millions and millions of lines of code systems. That's what I do. That's what I've been doing for the past, 15 years. That's my biases are definitely towards things that will help with that kind of environment. The systems have lots of moving parts. It's not a large system that's really simple. It's a large system which is very complex. And this software lives for a very long time. It's measured in decades. So any time someone's working on a code, like it's 99% of the time or 90% of the time that they're working on code that was written by somebody else. Okay, that's just the environment that I work in. And these systems undergo continual evolution. New features are being added. They're not systems that are just like in maintenance mode, you kind of chill. No, there are constantly things that need to be done to these systems in order to continue to keep their market share, increase market share, that kind of stuff. So these are my biases, and my primary concerns are, first one is the continuous operation of the system. If the system goes down, that's a big problem. This doesn't mean that I need these systems to have no bugs. I don't care if it has a bug. I care if it has a bug that's actually going to impact a user or something in a big negative way, right? So there's an important distinction there. And even if the thing works properly, if a user complains about something, that's a problem. So I care about that. And I also care about time to market. And when I talk about time to market, there are two different aspects of it. One is short-term and one is long-term. So short-term time to market, these are like, hey, I need to add a feature and hopefully I can get this rolled out within a month or whatever the time scale is. That's short-term time to market. But I also care a lot about long-term time to market because I want to make sure that 10 years from now, when somebody else takes over the system, that it can be just as agile as it was when I had it. So that means I can't have technical debt just grow and grow and grow, and our time to market increase and increase and increase over time. So I have a long-term time to market bias. I'd rather release a feature a little bit later now in order to be able to keep that long-term time to market in a reasonable place. So these are my biases. Hopefully you're okay with that. This is how I'm looking at Rust. So some more caveats. I am not a Rust expert, like by any means. It just happens to be the case that I'm not a Rust expert, so sorry. I've never done a large-scale project in Rust, like large-scale, like the kind of projects that I work on. There are very few of these out there right now, so that's not a surprise that I don't have that experience. There's not a lot of people that do. So I'm going based on my experience in large-scale development, looking at Rust and seeing, imagining what it would be like doing large-scale development in Rust, okay? Cool. So who cares about Rust? Why were we even having this conversation? I get a lot of emails. Do you get a lot of emails? Yeah, I get a ton of emails. I get a lot of recruitment emails, recruiters reaching out to me. Do you get those emails too? Okay, so yeah, I delete, but every once in a while I'll kind of pay attention, just like, what's going on in the recruitment world. And I noticed more and more recruiters reaching out, looking for people to program in Rust, right? And it just kept on increasing in the numbers. And the kind of work that they were doing are, first off, these were small companies, right? But they were small companies building system software that they would become the next large companies. They'd become the next Adobe or the next Bloomberg or whatever. These companies are basing their software capital on Rust, right? So that makes it interesting to me. I want to figure out like what's going on here with this Rust thing. It's worth looking into. So some statistics about Rust. I took these from the 2021 Stack Overflow developer survey. That's, I think, a reasonable survey. I'm sure there's like selection bias, but there are 83,000 respondents to the survey that they had, which is a big number, right? So I think they're significant. I mean, the numbers might not be exact, but they'll tell you something. The first one is that for every 10 C++ pull requests on GitHub, there's one Rust pull request on GitHub. Okay, there's a lot of C++ software development going on. So having 1 out of 10 in GitHub, that's a big number, okay? That's significant. And then for every 3.5 professional C++ developers, there's one Rust professional developer. I couldn't believe that. Like, I don't know that many Rust professional developers out there, but this is what they got from their statistics. And, it could be off by a factor of 10. Even if it is, it's still a huge number, right? So there's something going on with this language. I think it's something that is worthwhile that we should look into, but it was also voted as most loved language for many years in a row, right? Why is this systems language, versus all these other languages, JavaScript or whatever, why is Rust the most loved language many years in a row? That just means it's worth looking into. So I did, and we're gonna basically see the results of my looking into this language. Here's what Rust pitch is from Rust's point of view. They say we're performance, like we care about this. We wanna have fast and memory efficient applications. That's one of their focuses. If you want that, then you should look at Rust. That's what they say. They also say that reliability is a really important part of their concerns. They have a rich type system. They have this ownership model guarantees. We'll talk about that like way later in the talk. And they also have a pitch about productivity. They have good documentation. They have what they call a friendly compiler. They have great tooling. Now, this is just what Rust says is great about itself. My perspective, I would not say these are the cool things about Rust, right? This is just what Rust says is cool about Rust. So let's look into see what I think is cool about Rust. First one is language variants, or what Rust calls enums. So this is a C++ code here, right? We have this enum class color. It has 3 enumerators, red, green, and blue. You've all seen this before. You can create auto C is color red, and then you can also do C equals static cast color 3. Is that okay?
Yes.
Does anybody think that's not okay?
What do you mean by okay?
What do I mean by okay?
Yeah, that's a good question.
It is a good question.
It's not you.
From the so let me just explain. So this is totally fine from the compiler's perspective, right? Because when a C++ compiler sees an enum, what it thinks is, oh, like an enum class, this is basically an int with 3 defined constants, right? But it can be anything else that fits within the int, okay? So that's totally cool with C++. It's fine. People don't use it that way, but that's what it is. Yeah, you hope, but it's named constants. All right, so here's what Rust looks like. The enum looks the exact same. Can anybody spot the difference between this enum and that enum?
Class.
There's a class. Anything else? Semicolon. Yeah. Okay, but really, really similar. Okay. Now, now if you look at this line 9, where we make a mutable variable C, so you can probably intuit like what this does. You're just creating a variable called C. It's kind of like our auto. And then we assign C to 3. This is an error in Rust. In fact, there's no static cast. There's no way for you to create a value of this enum type that isn't red, green, or blue. It's just, it doesn't allow you to do that. It's not a int with named constants. It's just one of those 3 things. All right, that's how it works. So, yeah, this is what I just said. This is kind of similar to a variant, right? So how do we do this with a variant in C++? Something like this. You create these classes, red, green, and blue. They have no data members. And then you have a std variant, red, green, and blue. And we're just calling it color. This works. And this, there's no way to make this variant for. It just doesn't make sense. A variant is just one of these 3 things. So, yeah, you can do that. in C++, but it's kind of ugly. Like, look at all those classes. It's just like a lot of syntax. A unique type wasn't really introduced, right? Because we'd have the using declaration there. Someone could, make another variant that calls this something else. So there are ways to get around that, and then it just makes it even more ugly. And then there are, just basically like variants aren't supposed to do that, right? That's what enums are for. Variants are supposed to have, the different alternatives are supposed to have more than one value. That's just what it wasn't. It wasn't designed for this. So you should just use an enum. Well, enums in Rust can carry values. So they're very similar to variants in C++. So here we have a game event, and here we have player died. So just like the Rust enum on the other screen there, this is just like a possible alternative that this could be. Then you have key press, but this carries a value with it. This carries a char with it. And then here we have click, which carries two float 32s with it, one called X and one called Y. Okay, cool. So how do we use this thing? Well, this is just like the simple enum case. You just assign something. If I want to make it a key press, then I just pass in the parameter for what I want the value to be when it's that alternative. And then similar for the click event, I say I want X to be 0, Y equal to 10. So this is basically a feature of Rust, which I think is pretty cool. If you want to get the value out of this thing, you have this match construct here. And here you're just kind of like opening it up and saying like, oh, if this happens to be a player lost, do this thing on the right. If this happens to be a key press that is either lowercase q or uppercase q, then output q key pressed. And this is called pattern matching in Rust. It's pretty cool. And you can just get a little bit of the sense of the power when you see something like this, right? You can nest these patterns. They can be arbitrarily complex. And here's a key press for anything else that isn't q, and the underscore is your wildcard in that case. And again, click here, we have X and Y, and now we can just output X and Y. This is how you use it. Syntax is pretty compact. It's pretty nice. So what would you do with something like this? There's this library called pull down CMark, written by Ralph Livin. So this is a pull-based parser. Now, when you talk about parsers for something like Markdown, you have a couple of different varieties. One would be you parse your Markdown into an abstract syntax tree, right? It's like a DOM-style way of parsing things. So that's one way of doing things. It has a certain set of trade-offs. It uses a bunch of memory. You're kind of stuck with this AST. The other style that people frequently do is more like the SAX style. So you parse it, and then you pass in this big visitor with a bunch of member functions that handle the different cases of what things are like. So this is a different way of looking at it. So he would call that kind of SAX style to be push-based. It's pushing information and your visitor just kind of reacts to it. So this is a pull-based parser. And just to give you a little kind of a flavor of what it looks like, try not to get too hung up on like this line 1 here. But essentially what this block of code is doing is it says, when you happen to see a soft break, convert that into a hard break. If there's anything else, just ignore it. Right? Just a little tiny snippet of code that basically filters your markdown and does a replacement. This one here is probably a little bit more practical. If you happen to have TEH as a text element in your markdown, then this will replace it with THE. And there's some other syntax here which I won't go into, but the key thing to take away is you have these really lightweight pieces that you can compose together in order to do a basic task like markdown parsing. I think it's kind of cool. So what do I want? I want language variant support. Okay, I want Rust enums. If you have access to these things, you'll realize really soon that these are almost as ubiquitous as classes, like I did in a sec. And you'll realize that this is a basic tool. This is something in your toolbox that you will reach for all the time. We do things in really funny ways in C++ because we don't have something like this. And variant's the closest thing, and the syntax is terrible.
Yeah,
So,
variant should be a language construct.
I'm sorry?
Variant should be a language.
Variant should be a language construct. I very much agree.
performance time is when you have this, let's say you have a big enum with all these associated values, like your game events. Sometimes you want to express a function that just works for one of these game events. And because it's not a type, it's a case of an enum, then you're not able to express a function for this specific game event. You need to take the whole enum, and at the beginning of the function, you need to say, well, I don't care about all of the cases, maybe I just crash there. And that's an issue with the type system you have. Your type system, you cannot single out a specific element. And what's also bad with that is, let's say you have your enum, you care about all cases, but
so it's the lack of a subtyping relationship you're talking about.
Yeah. So that's one issue. And a second issue is maybe you have parts of these cases of your enum that have a property or a function, but not all. And now you need to have those big switches to, every time. You cannot just use the subtyping relation. So it becomes cumbersome.
So the comment is that if you do something like this, you use something like this, basically when you do your pattern matching, you got to consider like all the values. You can't just write a function where I only care about like these two or this one. And that's true. That's one of the trade-offs of it. And the other thing that you said, I'm not going to repeat that. I think it's kind of related. So yes, that's true. But I still want this. Yeah.
So, I mean, Dimitri and I are taking this feature to task because we have the same feature in Swift, and it's way better than what you have in C++, for sure. Big improvement, but it does get cumbersome, and maybe you might do better with the variant with the subtyping relation.
So,
I think it might really do better, partly because you can recreate this thing using that system.
So the comment is that there's some work in improving this even better than what Rust has, and maybe this would be a special case of a more general facility. Cool, that's great. I still want this, right? As long as I get this at some point, like I don't care. So pattern matching. So this is something that you need if you have language variants, because otherwise you can't like break open the value. But these pattern matching is useful not just in like the language variant case. It's useful in a lot of different cases to simplify code and make it more readable. So this is what I want. All right.
Bjarne has a couple papers out from like the last 5 years on adding pattern matching to C++.
Oh, there's the comment that there's been a couple papers out in the last 5 years on pattern matching in C++.
Bjarne.
By Bjarne. Yes, I know. I happen to be a co-author of those, or at least some of them. So
There you go.
So I wrote a paper in 2015. Okay, this is a while back.
7 years, not 5.
This is when we were discussing, and we're talking about the gap, by the way, now. This is when we were discussing whether we want to have std variant in C++ 17. And there was a lot of debate about what the meaning of std variant should be and all that. And I wrote this paper after I thought about it a little bit. I didn't know anything about Rust, and said, like, this is what I really want. So I called it enum union. And basically, you put the type on the left and the identifier on the right, so it looks a lot like normal structs, except that the difference between this and a normal struct is that you're one of these 3 different alternatives here, and they carry this stuff on the left as the values. Okay, this is primitive, right? This is old paper. And then for pattern matching, I just used switch. There's a lot of reasons why this particular syntax wouldn't work, but this was presented to the committee back in 2015. And the committee said, yeah, we actually want this. Everybody was in favor of it. There was only one person that was strongly against, and that happened to be Bjarne, which is unfortunate. But really, the committee wanted this. I think Bjarne just needed to learn a little bit more about it. The hurdle here is complexity with getting this in C++. There is like opt-in syntax right? How do you get your custom type to be able to opt into pattern matching or opt in to act like a language variant? There is pattern matching itself, which is a big topic. And then there's language variants, which is separable from these two different things. So there's just a lot of work that goes into this. One of the big issues is the exception thrown on construction piece. The same issue that we had with std variant, it also happens with a language-based variant. And I don't know how to solve this problem, right, in a clean way. And there's probably a way, I haven't been able to figure it out, and nobody's had an idea that has been convincing yet. Backwards compatibility is a big challenge. In just a sec. So using underscore as a wildcard was a big issue because some libraries out there used underscore for something, libraries that people use quite a bit, like gmock. And so we're like, okay, well, maybe we can make it like a context-sensitive keyword. And anyway, it got rejected, and basically what we're left with is like a double underscore as our wildcard, which is just like, oh. But anyway, I mean, it's an example of the complexity that we have to deal with when we're trying to put a feature in like this.
Sorry, just regarding your previous comment, I was wondering, just like a while earlier, maybe limit to no except, types that have no except constructors.
So the comment is maybe one way to solve this is only have types that happen to have no except constructors, and there's like various permutations of that as a possibility.
Limits the possibilities, but on the other hand, would give you something that's cleaner.
Yep. So that's definitely one of the options, and it's totally valid. I don't want to go into that here because it's a big topic and looking at the alternatives and the trade-offs. But we should definitely talk about that later for sure. The other thing is that there's competing visions for the design. So we were pretty far along with the pattern matching discussion, and then Herb Sutter came out with his pattern matching paper, which had a completely different syntax. And ours was based on pattern matching in other languages. We were kind of building off of that kind of tech, and he rethought the whole thing. So I'm sure we'll get through it. It's just, it slows us down, right? Did I mention that this was several years ago when this was originally proposed? So we have the latest papers. One of them is P1371 R3. This is Bruno, Sergey, Michael Park, myself, Dan Sargensen, and Bjarne Stroustrup. And yeah, you mentioned that Bjarne was there. It's true. But okay.
Mostly I remember going to a presentation with Bjarne gave.
Yeah, sure. Maybe I think he also wrote another paper which didn't include these co-authors that was kind of with some of his ideas. Very cool though. So the other one is pattern matching using is and as by Herb. So this is the other syntax. And work just kind of has paused at this point. I think that people are overwhelmed with a lot of stuff, but also realizing like this is just, it's gonna take forever. And it's not even a sure bet that we'd get it in there, right? That's the gap. Okay. Cool. Let's talk about something else. Let's talk about reflection and injection and active use. All right, and we'll see what I mean by active use in a minute here. But let's talk about C++ first. So there's this library called CLI 11. Okay, it's a cool library, right? It's decent. I think Bloomberg recommends this for modern code. Not that it matters to me anymore. But basically, you create this app object. You have a std string called file name. This is assigned to default because that'll be the default for this. You call app.add option. So you have -f, --file. I mean, you can kind of intuit what this code does. It's not that complicated. And then you have another debug argument. And then you have this macro here.
But what's going on with that third argument to add flag?
The
Is that C++ syntax?
The third argument to add flag.
Oh yeah.
Oh, sorry. There's a typo there. Yeah, thank you for pointing that out.
I was just wondering what magic allowed that.
Yeah, no magic.
It's totally legal.
You know what?
It's an expression.
Let me tell you something. This I copied and pasted from the CLI 11 example, and just keep this in mind because we're going to talk about something later on that's going to be very apropos to that bug. So Anyway, they created some kind of a macro because people feel uncomfortable with try-catch blocks. I don't know why, but anyway, you don't have to use a macro, but this is their example. Okay. So one thing I really hate about this, and most of these libraries, I shouldn't use the word hate. One of the trade-offs that I really don't like is that const doesn't work, right? I don't want debug to be a changeable thing, right? I don't want to have to worry that it'll be changed like somewhere lower. I want to have like a lot of const so that I can reason better about my program. So that's just one of the drawbacks of this library. Unit testing is tough with this. I don't see people unit testing their argument parsing a lot because the libraries just they don't really look like they're tough to unit test. You have to do a lot of extra work.
Talk to me afterwards. I'll explain how to do it. It's not a big deal.
So the comment is, talk to me afterwards. I'll explain. It's not a big deal. But still, I don't want it. All right?
Okay.
Because I'm going to present an alternative, obviously, right? So let's look at Rust. All right? Rust has a library called structopt. So basically, you create a struct, okay? And note that there's some like annotations above here, right? This is basically opting into their metaprogramming thing. And you have about equals app description. They're basically adding these annotations. And what it's going to do is it's going to transform this code into something else, okay? Here we have debug, all right? It's a bool. And the annotation here is structopt, which is the name of the library, short and long. What do they mean by short and long? Short means I want to have a dash D. Long means I want to have a dash dash debug. How does it know dash D and dash dash debug? Well, it's the name of the variable, right? It's able to pull that out of it. That's pretty sweet. I don't have to repeat myself. Here's another one with the file argument. And we have short, long. We also have a default value in there. We have a help string, all these kind of like extra annotations. And here's what it looks like in main. I call this function that got synthesized from this called fromArgs, and it gives me a value of this type. And there isn't a mute here, right? So this is actually const. I get the const that I want. That is sweet. That's what I want, right? I want to define the data of what I want to be the post-parsed thing and what I want it to go into. And I want it to do all this stuff for me that I don't really care about. I saw a couple hands up. I'll start with you.
Is fromArgs a member function of opt?
Oh, the question is fromArgs a member function of opt? No, it is not. It is like a static function call.
It's an associated method, I think is what it's called.
Someone said it's an associated method. I'm trying to use the C++ lingo here, so given the audience. All right, another comment.
Also, another benefit of this, it does a lot of this work at compile time rather than constructing a parser at runtime.
Another comment is that it does a lot of this work at compile time as opposed to constructing a parser at runtime. That's cool, but for argument parsing, that probably doesn't matter as much for my use cases. We got a comment in the back there.
Did fromArgs parse the arguments, or did it create a parser?
The question is, does fromArgs create a parser, or does it actually parse the arguments? It's the latter. It parses the arguments. There's like a way to get the arguments that got passed in, and it uses that. Yeah. Any other comments, questions? Red Sea.
Does this not look ugly to you? I mean, this looks a bit like macros. I'm not a Rust guy. I'm just a regular C++ guy.
So the question is,
like a bunch of macros, which we sort of tend to frown on anyway.
so the comment is, doesn't this look ugly to you? It looks like a bunch of macros, which we frown upon. Well, beauty is in the eye of the beholder. I will talk about how the Rust metaprogramming model is implemented, which is actually not great. But what I want is this functionality, right? I don't care about the syntax. I want the functionality.
Okay.
All right. I see more hands. Like, do you really want me to do it? Okay. All right. Go ahead.
Strictly speaking, this is not the most crazy functionality you can get when doing algorithm parsing. Python has this thing that allows you to derive the entire parser from docstring. C++ can do that as well.
Okay, there's a comment that there's some Python library out there that can derive the entire argument parsing from like a comment string or something like that. Okay.
So all the features you say you like about this, you can do in C++, and I've done it. I can show you afterwards, but there's an argument parsing library that does exactly this way.
Okay, there's a comment that there is an argument parsing that does it exactly this way. I don't disbelieve that, but this is the library that we actually use in most C++ code. So I'm just going based on what's actually happening. I still want this. So I'm going to move forward because we got a ton of material. Okay. Anyway, yeah, it's declarative. I don't repeat myself. I can easily write tests for this code. Got it. Another thing that's kind of cool is that when I put -- help on this thing that got generated, you see how the help string for -file, it says a help string. Obviously, it pulled that from the thing, but it also pulled the default argument, right? It just threw that sucker right in there. Now, if I was doing this in CLI 11, I would have to make my doc stream mention the default. Now, that's just another thing that could get out of sync with the actual default. I just think that's kind of cool. All right, let's talk about F strings. All right, C++ had an evolution of how we output things, okay? We started out with this, cout, I is I, and J is J. It's long, there's a lot of syntax. This is the kind of thing that gives C++ a bad reputation. It was probably cool at the time, but not anymore, right? So in C++ 20, we added this std format thing. So std format returns a string, and it looks kind of like printf, except it has more guarantees about the correctness. It'll catch some errors at compile time. It's better, right? And then in C++ 23, we made std print, so we don't have to do cout std format, because this is going to be really common, obviously, right? So this is just the evolution of what happened in C++. Now let's look at Python. Python actually had a similar evolution, except they started with something a little bit, well, I guess they started the same, kind of like line 6 up here. You have commas, it's a little bit tighter syntax, but they still wanted to do something better. So then in Python 2.6 in about 2008, they added the curly bracket notation, and you basically have string.format, and that's where you put in your substitutions essentially. And then in Python 3.6, they did something completely crazy. They're like, you know what? I'm just gonna put the expression that I had on the right-hand side like right in line, right? They put the curly brackets and they just put the expression right there. And they're like, we call that F strings, right? That's where the F comes in. Okay, that was just the evolution in Python. And you might recoil at the hideousness of this, but if you've ever written a bunch of code that has to output stuff, like this is nice, right? If you have access to this in Python, you use it. It's cool. So now let's talk about Rust. Rust started out in 2018 and earlier with the Python style syntax. That was cool. And then in 2019, somebody's like, hey, this Python F-string thing, like that's kind of cool. Let me see if I can implement that with Rust metaprogramming. And they did. And so you can see that this was like a library that I pulled in where they implemented F-strings. That's just like really powerful metaprogramming. And since like, I don't know, a couple weeks ago actually, they just added this to the Rust standard library. And now it's there. But look at the timetable, like 2018, 2019, 2022. They just like boom, 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 added this stuff. That's really quick evolution, which is a nice thing.
How do you opt out of that if you want to actually print the curly brackets?
So the question is, how do you opt out of that if you really want to print the curly brackets? I don't know. Like, you could figure it out somehow. Okay, everybody's answering the answer. Like, it doesn't matter. There's a way. Okay, that's it. Let's move on to another cool result of having good metaprogramming facilities. There's this thing called Rocket. Okay, look at this function. This function, you should be able to understand this function. It takes in a name, it takes in an age. The name is a string, the age is a unsigned 8-bit int. And it just returns a string. There's no return here. You can kind of like elide that in Rust. And you call format, and basically you return the string, hello, 12-year-old named insert X person who I want to make fun of today. So then there's this piece, right? where they're adding this like annotation. And what this is doing is it's saying, go ahead and make this into a piece of an HTTP server where if you give this URL, hello/name, which is a string, /age, which is an age, and it will just make sure that name is actually matches string and age actually matches this U8, and it will reject anything else. And you just synthesize a web server with that one line. That's really convenient, right? That I'm just thinking about like what that looks like in C++, and it's just like, oh, like that's just so much. But this is like the essential thing that you have. Okay, and I will say that in terms of this Rocket library, which is super interesting, this is just scratching the surface of the powerful library that this thing Rocket is. It's very cool.
Okay, so I agree with you looking at that slide, but basically, I mean, okay, so in C++ I could write this class, and it gets the parameters and do whatever I want, like behind the scene, and make the service. So, like I'm trying to say.
Mm-hmm. So
Yeah.
there's a comment that you could write a C++ class. I mean, there's some of this you can do in C++, right? You can get the types of the arguments. You wouldn't be able to get the identifiers. But yeah, I mean, you could do some stuff.
Yeah, just to say that it is actually a proposal of considering the identifier, but what I'm trying to say is basically that maybe you're comparing something that is like, so I could do it in C++ to have that be done in one line, and yeah, of course there's more work behind it, but maybe what you're looking for is the library edition.
So the comment is, maybe what you're looking for is a library edition. We will get to the gap in a minute. Okay, comment.
If I'm the kind of person who doesn't read documentation, theoretically, yeah, just let's say, does this mean I have to read macro metacode in order to understand what Git does?
So the comment is, if I don't read documentation, am I going to have to read the code?
No, macro metacode.
Am I going to have to read macro metacode? I mean, I guess. Like, yeah.
But
So
that's an important comment.
No.
Do you have to read templates?
You can't do anything
okay,
without
I mean,
documentation.
sure. Like, let's keep moving on. Like, next question.
I think David is perhaps showing us examples to demonstrate a wider feature that he wants, and maybe it would be beneficial for us to not focus so much on the examples and get to the wider point that David wants to make.
So the comment was Elmo, which stands for enough, let's move on, I think. All right. What do I want out of metaprogramming? I want the libraries that the metaprogramming power produces. That's what I want. By the way, the mechanism for this isn't great in Rust. Like, even if you look at the Rust book in the section on macros, it tells you like, hey, this isn't great. Gives you some examples, and they say like, we're working on replacing this. And the state of the art is like, well, actually, people aren't really working on replacing it. It's just kind of in a sucky place. But by the way, Circle makes all other languages look really primitive in terms of metaprogramming here. So it's just,
Circle?
huh?
Even Circle?
Circle, let me tell you what, Circle is so awesome, it makes Circle look like crap, okay? So also, by the way, I don't care. I don't care if it isn't great. I just want to use the results. If like a few people that are experts in this like go off and make the libraries, I don't care, that's fine. I don't actually need to do this myself. If just a few people can do it, that's okay with me. If it's an easy to use thing that everybody loves, more power to you. But like for my use case, I'm fine with just a few people having access to this. Dave.
What happens when you misuse these libraries? That's really the key thing. If they manage to make that good, then I don't care how ugly it is.
So the comment is, what happens if you misuse these libraries? So I did try to do like the web server thing in Rocket, and I will tell you that I wasn't like, I didn't think the error messages were hideous. I wasn't like, oh my gosh, nobody's going to be able to use this because of the error messages. I thought they were good enough, whatever. That was the impression that I had when I walked away from it. Now, maybe they're not great, but good enough is what I walked away with. Okay, So, what's the gap? Like, what's the gap to getting this greatness in C++? Well, there's this reflection TS that got created by Matoush, Axel, and myself, and this gets us some of the way there, right? But this isn't in C++. There's another paper called Scalable Reflection by David, Wyatt, Andrew, and Faisal, and this is basically, so reflection TS was written using template metaprogramming style programming, right? It's using a well-understood facility for doing metaprogramming that everybody hates. Now, this is using context-expert metaprogramming, this later paper here. The problem with this is that, well, context-expert isn't really feature complete, so we need to add a bunch of features to the language in order to make that work. So there are controversies around this. There's still an ongoing controversy as to whether we want template metaprogramming or context-expert metaprogramming for reflection. Like again, my position is I don't really care if it's a bit ugly. I just want the feature. So I would be completely happy if we just took the reflection TS and like threw that in the standard and continued working on making something better. But I think I'm definitely in the minority there. There's also a big controversy about whether we want a type-rich or a monotype kind of library. So type-rich means that if you reflect upon a type, then you get a meta type. If you reflect on a value, you get a meta value. A monotype approach is more you reflect on a type, you get a reflected thing. You reflect on a value, you get a reflected thing. It's like all the same type. So it's an API design question, and there's ongoing controversy, but this has been paused. I just haven't continued working on this paper. There was like a compromise paper, and that was it. And then there was circle metaprogramming, which got completely and utterly rejected. We should talk a little bit more about that. So, circle style metaprogramming. This is the clear winner in terms of metaprogramming. Why was this a problem? People mention security as the primary concern. They're concerned about security because if you compile with something that powerful, you might end up compiling, you might be running third-party code at compile time, right? It can be scary if you've never had that before, but it's not an issue for Rust or Python or like 8 million other things, but whatever, for C++ apparently it's a problem. The reality here is a big paradigm shift needs to overcome serious inertia, right? And C++ has a lot of inertia. Now we could continue fighting the battle and say like, hey, we want something like circle metaprogramming so that we can have this power. We can try to push that and get that turned over, but given the state where it is now, where it's like completely and utterly rejected, and where we need to be to where we have consensus, that could take years. It's like a lot of effort, a lot of papers, and all that kind of stuff, and there's no guarantee of success. So who wants to take up that battle? Sean, do you want to take up that battle?
I saw how well it worked for you.
Okay. So it's an uphill battle. I don't know how that can happen. So I talk a little bit about this in my Don't Context Expert All the Things talk, including a completely video of what happened in the committee. It's fun. If you haven't seen it, check it out.
Is there any build system that does not involve running arbitrary code at build time?
Is there a build system that does not involve running arbitrary code at compile time?
Like big files do.
There are, but they're limited, right?
The comment is there are, and there's limited. I don't want to go down that rabbit hole. Like, we can later, but you get the idea. Like, for sure. All right, there's a bunch of tools for systems engineers in here. Some of these are big things, some of them are small things. There's the memory safety features, right? If you have a mutable thing and you take 2 different references to it and you try to output the 2 different references, in Rust you're gonna get a compiler error. It's like, look, you can't have 2 different references to something. There's a lot of stuff in there to prevent certain classes of errors. I'm gonna say this is a nice to have. It's not that big of a deal. Where am I making this like extremely bold statement, since a lot of people say like, this is Rust's key feature? I just haven't seen a lot of production issues due to bugs like this. And I've sat in a lot of postmortems, and I love postmortems. I just haven't seen a lot of production issues that stem from these kind of memory issues. I think that it's because it's largely mitigated in C++ with other things, like sanitizers, ASAN, UBSAN. This covers some of these cases. Training helps out. Best practices, people are using smart pointers. They're using abstractions.
I see you didn't go to my keynote.
There's a comment that I didn't go to Dave's keynote. Yeah, sorry about that. I was busy. So, all right. So here's another cool thing. It's called unimplemented. It's pretty basic. We have a struct point. All right. Basically, so this is where you write your member functions in Rust. Just ignore that part. But basically, I have a function that I have declared here called origin. It returns a point. In the body, I just threw this unimplemented thing. And that compiles just fine. Like here's a function called foo where I match different things. And part of it, I just threw this unimplemented piece here. Why? Why do I want this? Well, if you're doing top-down interface style development, it's really nice to be able to start with like, hey, I'm going to write the example. This is what I want the top-level code to be, and be able to put unimplemented for the various pieces. So I like that. It also allows for better compiler and editor interaction. Like I know there are people who are like, I get so upset when I see the squigglies under my, my words when I'm writing my email. Okay, that's cool. Like I don't get upset. I actually like that, so I can right-click and fix it real quick. And a lot of people like that in their IDEs in terms of their programming. They want to see the squigglies when something's an error so that they can kind of look at something which is going to compile. So that helps with that. What's the gap for C++? I don't know. I mean, you could use something like declval for this if you wanted to, but then you have to specify the type, which isn't great. Maybe some kind of compiler intrinsic, more powerful metaprogramming. Could you do this? I don't know. I mean, basically, just someone needs to write a paper and investigate it. And the comment was, we need a bottom type. Yes, this is exactly what this is a bottom type.
How is this different from just built-in unreachable?
It returns something that can be used as anything.
So the question was, how is this different from built-in unreachable? And the answer was because it can return a value of any kind of type. It kind of deduces the type piece. Okay. Another thing I think that is cool is side-by-side tests. So here we have a function foo that just adds 41 to A, and here we have the test for it. So what? But the thing is, this is in the same file, right? I have the function, and then I have the test in the same file. There's a comment.
I have seen at least one C++ library that does do this.
The comment was, I have seen at least one C++ library that has done this. I have two, and we'll talk about the gap. So why do I want this? Well, it's generally agreed upon by everybody, except for Sean, my new boss, that documentation should be close to the code, right? People like this. The same is true for tests. The same rationale is true for tests. It'll be accurate, up to date, less likely to be missed. What's the gap? Basically a proposal. Someone needs to do this. You could do this with static initialization hacks. I've seen libraries like this, so you can do that, but that's like, there's a lot of terribleness in that. Do we want to encode in the standard different compilation modes, one for your test, one not for the test? That means we'd have to have agreement between different build systems. I don't know, it's tough. It's tough, it's maybe possible. Dot comments. When you're writing large-scale systems, you care about comments. So here's our function foo again, and then here is the dot comment. Okay, so what? It's markdown syntax, who cares? Look at the code in there. What does Rust do for me? So what? I mean, I can do this in C++. RustDoc will verify that the code in your example compiles. That is sweet. It will verify that the code actually works. It will run the code and make sure that your examples, like with this assert here, are actually do what they say they're going to do. That is pretty freaking sweet, right? And remember when I was talking about that thing I copy-pasted from CLI 11 documentation? If they had this, there wouldn't have been a bug in my slides. Okay. Why do we want this? Well, keeping examples correct is expensive. You have to be very careful about running the code and then copying and pasting it to update it most of the time. What really is just keeping examples correct is just unlikely because it's so much work. And what's the gap? Well, we have DoxyGen, which is the most popular system, and DoxyPress is now gaining more popularity. We need this additional feature in one of these systems. Well, build system issues are going to be a major complexity here. because like how does the documentation system going to interact with the build system to be able to check this code? And we don't really have an organization to drive this kind of change, right? WG21, the standardization body, they drive the language, right? They wouldn't drive a feature in tooling as much, or I don't think it has, and I don't think it has appetite for it anyway. So that's what the gap is.
SG15 chair, I'd be willing to hear papers on this.
The comment is that the SG15 chair is willing to get papers on this. Great. And then we just need to get consensus on those papers. Yes. Bryce.
As the former SG15 chair, it's not going to go anywhere.
The former SG15 chair says, yeah, but it's not going to go anywhere.
SG15 is the tooling study group of the C++ committee.
SG15 is the tooling study group of the Standardization Committee. Thank you for that clarification for those in the audience that were not aware of that. Okay, cool. Let's move on to something else. Let's talk about concurrency. Okay, I am not an expert in concurrency. So the thing that I want you to take away from this code, we're going to work through it, is how simple it is for somebody to be able to program with it. Okay, so there's this thing called channel in Rust, and here we create what's called a bounded channel, and you have an S and an R. The S is the sender and R is the receiver. Okay, and bounded 5, that means that there can be no more than 5 things in this queue at a time, right? And you can have a bunch of different threads throwing things into the sender and a bunch of different threads pulling things out of the receiver. And the way that you do this is you basically clone the sender and then move it into your thread, and then the thread will use that to send things. And then here I have just 2 different threads doing that. And then the receiver, you can clone that too, but we're not doing that here. You call assert, well here we just call r.receive, and then you get the value out of it. Okay? Synchronize between threads.
I'm sorry, I keep seeing this move double bar syntax. I've seen it in other Rust examples.
Mhm.
I don't get it. Is that moving S2 somehow? How is it referring to S2?
Okay, so the comment is this move thing like is tripping me up. Like this tripped me up too. It's basically saying, so this is creating an anonymous function, and it's saying to have the captures come in by move. That's what that's doing. Yeah, yeah. Sorry, it's not obvious.
I get it. It's fine.
All right. So the standard library actually has one of these. I use this crossbeam library, but the standard library has one which is slightly simpler called MPSC. I think that's multi-producer, single consumer, whereas this one is multi-producer, multi-consumer. But at any rate, it's there, it's accessible, it's really easy to use, okay? And they use it. And this eliminates a bunch of common error classes when people are trying to do mutexes and stuff like that for synchronization. So, why do I want this? I want it because engineers run away from concurrency in C++, and they should, right? Because they're going to screw it up. And then when they do concurrency in C++, they reach for the error-prone tools that come with the standard library. They reach for mutex, they reach for std thread, they don't use like higher level abstractions, and it's just a disaster. So that's why I'd like to have something nice that they can use that isn't a foot gun. What's the gap? Well, we do a lot of bottom-up design in C++ as opposed to top-down design. And when you do a bottom-up design, you typically don't get things that are very user-friendly or ergonomic. And it's just, we do this a lot in C++. So we need to kind of change the way that we think about things and maybe do some things that are top-down. There's also big disagreements about standard library scope. Some people think that the standard library should only be like the absolute lowest level of things, the bits and the twiddlies, okay? We'd have to get over those disagreements if we were going to get something like this in the standard library. And then there's also a big focus on completeness and generality, that this can be used everywhere versus, hey, this is going to be the ergonomic solution for 95% of our users, right? It's just, we need to work through these things. All right. Now we're going to talk about community. All right, this is a big one. We're going to talk about inclusivity. All right, the Rust logo is, or their single sentence thing is that Rust, a language empowering everyone to build reliable, and efficient software, and they put extra emphasis on empowering everyone. It's funny, when they talk about this, they're like, yeah, there's that other stuff, but like this empowering everyone is really a key thing, okay? Now, when I say inclusivity, I know that a bunch of you got like something in your throat and it's just like, oh. I just want to clarify what I mean when I say inclusivity, okay? When I say inclusivity, it is not silencing, oppressing, or removing folks that disagree with an ideology. It's not accepting one group by rejecting another. It's not mob rule. This is not what I'm talking about. Inclusivity is a mindset. It's thinking about, how can I reach out to these people that are currently not in my group? All of you here, you're in, okay? And then those who are not here are not. It's thinking about, how do I close that gap? How do I get them to come in, the ones who aren't part of this? That's what it is. It's about bringing people together. It's about doing reasonable accommodation. You know, what can we do to help people come in a reasonable way? It's about accepting people for who they are. It's about extending our reach. This is what I'm talking about when I use the term inclusivity, okay? All right, now let's talk about inclusivity in Rust. What does it mean in the rendering of Rust, since it's such a big thing? So this was the theme of RustConf 2020. I highly, highly recommend, if you have any interest in this, to watch the opening keynote of RustConf 2020. It was fantastic. You don't have to know Rust to watch it. It talks about how they built their inclusive community and what the impact of that was. One of the focuses that they have, this I here, you can't tell that it's bolded, but it is bolded. They want people to walk away from a talk saying, I can do that, right? Now, how many talks do we have in our community where someone comes up and does a triple backflip, and in the audience, you look at that and you're like, well, that was cool. I'm not going to do that, right? This is what they want people to walk away from when they hear their talks, okay? And it's the focus of the community. They want a community which is accessible to beginners. They don't want to have a place where if you're a beginner, you're going to feel out of place. You're going to be like, well, this is clearly for experts. I don't belong here. They want the community to be accessible to beginners. And they want Rust accessible to beginners too. Not just the community, but the actual language and all the tooling and everything around it. So they had this big focus on error messages for like a few years, where they looked at every single error message that came out of the compiler, and they said, how do we make this error message absolutely awesome? And if you get an error message in Rust, I can tell you it is so cool, because it'll say like, hey, here's the error message. This is probably where you made your mistake. And here's a link to a documentation of the common ways that people can get to this error message. And this should help you out. That's so nice. It's because they're focusing on it. Like we could do that, but they're focusing on it. Okay? Their code of conduct is cool. And one of the things that they have in their code of conduct, which I haven't heard anywhere else, is they talk about accepting trade-offs. Like if you see an idea which you think is a bad idea, frequently you'll say like, I think that this is a bad idea. I think we should go with this. They say, hey, here's a little tip how to make an inclusive community. Instead of saying, hey, I think that that's a bad idea, here's a good idea, they'll say, that idea has a certain set of trade-offs. Here's what those trade-offs are. I have this alternative idea, and this has this different set of trade-offs. Now let's talk about like the difference of the trade-offs. You see, now it went from a combative discussion into a mutual discovery of truth. I think that's really sweet. They also prioritize spreading knowledge. They really care about making sure that we don't have like a small group of people that are in the know and then a bunch of people that aren't in the know. It's like, hey, if there's something that people need to know, let's make sure that we give talks and we can spread this knowledge out. They do that. They also care a lot about the accessibility of their tooling. They say, they want to use GitHub versus emailing patches around because it's so much easier to get into GitHub and get a conversation there. They want to use Discourse as opposed to mailing lists. They want to use Discord as opposed to IRC. These are intentional decisions because they would like to make their community inclusive. I think that's cool. Mentoring and community building are also considered absolutely essential as part of the discussion that they have. So, what's the gap in C++? Well, we probably need some organizational help, right, to carry a vision out like this. There's the C++ Alliance, the C++ Foundation, the Boost Foundation. These are possibilities. Also include C++. This is kind of their MO. But they need to decide that this is what they want to do. And also, what is the strategy? Is it like cooperation, or is it making demands? Like I've heard many times, like, I will not go to your conference unless you do this or that or this kind of thing. What kind of environment does that create? Is it an environment you want to be part of? An inclusive environment? I don't know. I don't like that environment personally. How do we channel energy productively? You know, someone gets really upset about a particular thing. How do we channel that into a productive channel as opposed to a destructive channel? Like, we got to think about this. We got to decide. Do we want to change existing structures? Like, say, like throw out ISO C++ and like replace it with something else? Or do we want to work with existing structures to try to improve them? Okay? Like, we got to decide what we want to do with our strategy here. And then also we have to decide what is the goal. We can't focus on every single community at the same time, right? We won't be able to do very much. What Rust did is they said, hey, the community that we have missing right now that we want to focus on are beginners and people who aren't traditional systems programmers, like people who are using other languages like, you know, JavaScript or something, and to tell them like, hey, you can be a system programmer too. So we'd have to decide what we want to focus on. It could be women, there's like so many different things we could do, but we got to focus. So that's all I'm going to say about inclusivity. But one of the things that came out of it is this ergonomics initiative in Rust. And I love this quote from the RustConf 2020 keynote. I'll say it again. Please watch that. They said a paper cut for an experienced user can be a blocker for a new user. It's so true. It's something important to think about. They think about ergonomics, they think about it through everything. So remember that example that I had, that, you know, structopt thing? I just tried it, I just put like --deb. That's not correct. Here's what the output was. Found argument --deb, which wasn't expected or isn't valid. Did you mean --debug? And then it gives the documentation for --debug right below it. Why did they do that? They did that because they keep on thinking about ergonomics all the way through. So even if you, like just any Rust developer, your programs are automatically better because you used a library which is ergonomic. Now your command line arguments thing is better, right? I think that's pretty sweet. Another thing, like their package management thing, this is also part of their ergonomics. So I made this presentation using org mode, and in org mode, yes, it is the best thing ever. In org mode, I have this inline code block, right? And look at that first line up there. I have, you know, hey, this is a Rust code block, and by the way, I have these flags, and it depends on structopt. And what happened when I hit comma, comma on this thing and it compiled it? And ran it. It went and it fetched that package, which this is dependency of the snippet, and it used that to compile this, and then it ran it, and that was it. Even that Rocket example, Rocket, you know, think of this like big web framework, --deb, pulled it in, no problem. Like that is ergonomic, right? So I thought that was pretty cool. Another package ergonomics thing. Their hello world looks like this. You put cargo new, hello Rust, this is basically creating a new package. You go into it, you say cargo run, it compiles it, and it outputs hello world. What happened there? When you create a new package, it created a main.rs with hello world. Like how many times do you start an effort with a hello world example, right? They make it so you don't even have to type that in. It's like there. It's fantastic. So what do I want? I want to have the word ergonomics used as frequently as I hear the phrase zero cost abstractions in discussions, right? It's just not a word that we use that much. It's not a thing that we discuss very much. But we could start doing that. I would like to see a C++ ergonomics initiative, right? I'd like to see a WG21 ergonomics working group to consider things from an ergonomics perspective, because the other working groups, they really don't think about this that much. So what's the gap? Leadership. Who would be willing to lead an ergonomics effort in C++? 1, awesome. 2, awesome. Anybody else? Okay. The person behind you had their hand up. I know that this does not mean hand up for Marshall. Okay, you guys talk with me afterwards. If there's leadership, who would be willing to volunteer their time and effort into helping make C++ more ergonomic? 1, 2, 3, 4, 5, 6, 7, 8, 9. Awesome. We need to please come talk to me afterwards. Let's get all these names together. We need sponsorship and organization for this, right? Could Boost be that? Maybe. This is something doable. So, comment.
I just wanted to point out that almost everything SG15 works on is in the ergonomics space. So that's also a good place to dive into.
So the comment is that almost everything that SG15 works on is in the ergonomics space. Cool. Comment.
Whenever I've raised objections like this to language features of EWG, I generally get a response that indicates that C++ is made entirely out of paper cuts. There's very little appetite amongst the sort of, language lawyer people that are in EWG for this kind of thing. Because they're like, this is a language for experts, and
So the comment was that when the stuff is brought up in the standardization group, there's a big response of like, yeah, but C++ is complex. Like we don't care about that. We're experts. That's a very non-inclusive thing. It just is. Bryce.
Well, maybe we need different people in EWG then.
All right, Bryce said something controversial and moving on.
How much of this gap, at least on the language side, comes from good generative metaprogramming and the ability to use macros to make things smaller like that?
So the question was, how much of the gap is due to not having a good, powerful, generic metaprogramming stuff? I think it depends on the piece. Like some of these pieces need that, some of these pieces don't need that.
I'd like to kind of answer that question. I think that is a downstream symptom, whereas the inclusivity thing is the upstream driver for all of that. So that's where you get ergonomics, right? If you don't care about inclusivity for beginners and whatever, then you're not going to care about that.
So the comment from Dave is that basically if you get your inclusivity right, that drives all the other things. That's really the key piece there, and I totally agree.
So I wanted to wait till the end of the presentation, but I just want to say that that's a great presentation. I really agree with a lot of the things that you say. I would hope to achieve some of those, that we'll be able as a community to achieve some of those. So, yeah. And just the more technical thing, just the common thing I think that I've noticed in your examples and probably noticeable is that basically this is like writing English, telling the compiler what you want to get, just like with the server, and that could help C++. I agree.
Awesome. How am I going to repeat that? I'll just say the first thing that you said. This is a great presentation. Thank you. All right.
You're welcome.
So looking ahead, there's a lot here that's doable. There really is. Medium-sized language features, we could do that. Community building, cultural shifts, these are things that we can do. Like this is totally doable. We will do. Nice. Tooling, we can do tooling. But there's some bad news too. There's a lot in here which is really hard / impossible. Substantial language features, I don't know how to do this effectively in C++. Our costs are like 10 times higher than like the other languages in this space. Our latency is like 5 times higher. It takes us a long time to get things. Our cost is just huge to like push things through. We have a lot of baggage in C++, a lot of baggage. We've got backwards compatibility baggage. We've got big inertia problems, just where we've been doing things this way for a really long time, and it's really hard to change that. So I have a few questions for you. So first question is, do you think that is C++, do you think that it's under threat of becoming a legacy language?
Define legacy.
Define legacy, kind of like a legacy system, something you wouldn't use for new stuff.
Yes.
Yes.
Absolutely.
Okay, I hear a lot of yeses. Okay, here's
Less so than it was in 2008.
and the comment was less so than it was in 2008. Okay, cool. Now, is it inevitable that C++ will become a legacy language? Is this? Okay, I hear a couple no's. I hear a lot of yeses. Okay. There's a comment?
I mean, it's, you have to decide what you mean when you say C++, right? Down the road, like C++ as it is written today, I do believe that will be a legacy language. But it's always possible that we find a way to build a new language inside of C++, and that is C++. And you know, it's got some kind of backward compatibility mechanism. So
the comment was, and it's absolutely true, is that a new language could sprout out of C++ that is C++ and is compatible with C++, but like the old C++ style would be like a legacy thing. Yep. I think I saw your hand up first.
I think a more immediate threat is that it becomes a niche language.
The comment was, there's a more immediate threat that it becomes a niche language. And I saw hands over here.
My comment was just drawing a distinction between a language that you maintain for existing, or making new software where you don't have existing software assets, versus making software where C++'s core value add is your ability to reuse existing software.
Yeah. I don't know how to repeat that, but I agree.
Okay, I can think of few things that sound more depressing than the idea that one language that exists today would be in use as an active language for the entire length of the universe.
All right, so I'll repeat that. Lisa Lippincott said, I can think of few things more depressing than the idea that a language which is in use today will be in use for the entire length of the duration of the universe. So I'm going to ask one other question. Is C++ already a legacy language?
In many fields, yes.
Okay, a lot of discussion. That's great. It's time for the discussion. All right, so this is the end of my talk. We'll go into comments now.
You missed one of my favorite Rust patterns, which was type state, which utilizes the same memory mechanisms in order to get constraints on states in your program encoded into types.
Yep, so comment was, you missed my favorite Rust pattern, which is basically linear types, like type-based constraints. Yep, I'm sure that I missed a whole ton of people's favorite Rust features, so fair enough.
So I think the common criticism that was kind of raised by a few people implicitly of the macros that a lot of the things you showed depended on is that they're don't work in large code bases potentially, and there's not enough evidence of that in Rust or whatever. But we have that in Python. We have that in languages like Java and Dart. What is the status of banning reflection or allowing reflection in large code bases in other languages?
The question is, what is the status of banning reflection in large code bases in other languages? I haven't heard of such a thing, but I'm not super knowledgeable about it, so I don't know. Now, so as much as I want the audience, which isn't here, to hear all the comments, I think I'm just going to switch to let's just have a discussion, so I don't have to repeat everything. All right. So goodbye, audience on YouTube.